Alright gang, some of the concepts, and as a matter of fact of all of them, pretty much in chapter 14, we have already covered. So, that's good news, huh? Let's go take a look, see what we have in store. The object class, the equals method, the toString method. See, we've already covered that stuff. Polymorphism. Well, we could do a little bit more with that. What is polymorphism? Well, for example, we could stick a bunch of different objects of different types into an array list and have them treated as though they were all the same type, but they would exhibit different behavior. We ought to be able to do that. For example, that's polymorphism with arrays. So the object class is the superclass for all other classes. Everything is inherited from the object class, and the object class is where we get toString, and we get dot equals. Now toString and dot equals do not do what we want them to do. We want them to be able to compare our objects intelligently rather than just ask if they point to the same memory address, right? Because two objects, you know, you could have two cars that are red and you wanted to say yes, dot equals is going to return true if you have two cars that are red, not if it's just two addresses of the same car. And just like that, toString, we don't want it just to print out the name of the class, we want it to print out that it's a red car. So let's go ahead and give an example. We already know how to do toString, we already know how to do dot equals, so this is not going to take any time at all to go ahead and do. I thought I had Apache already loaded. As far as I can tell, we're on Lecture Z. That means if we have one more lecture, it's going to be Lecture Z2. We'll see about that. We've already covered the topic of interfaces. Maybe we'll toss that in this time as well. Let me close the door. Alrighty, I'm going to make a new project, Lecture Z. Get rid of the main, the package for it. Alrighty. Alrighty. What did I just do? Did I just tell it to not make a main class? That was moronic. I meant to just delete the package declaration in the path for it. Well, that's Lecture X anyways. Alrighty. Gonna add a class. Why not? Java class. Lecture Z. Gonna add public static void main to it. I should have just recreated it. Whatever. Shall not take long to do this. Public static void main string with a capital S, square braces, R's in square braces. There we go. Alrighty. So we're going to make a base class called, and didn't we do vehicle last time, or did we do car? I don't recall. We could do shape. We probably did shape as well. I tend to go for the same examples. We'll see. That would be okay. I know we've done Pokemon. What are we going to do? We've done books, we've done people. We've used up the entire world of possible examples. Just kidding. All right, so we're going to come up with a class called computer. Not even sure what I'm going to put in there yet. Nah, we could put the product name. Right, everything's got a product name. How about just string name? Right. Every product has a brand, right? Every product has a processor, right? Now we have cool computers nowadays, like phones and watches. So class watch, you know, smartwatch, extends the computer class. And what does the watch have? You know, the color of the watch band. And then we're going to have a class called phone, which extends computer. And it's going to have a string called carrier, right? All right, so as far as we are concerned, two computers are equal if they have the same name, brand, and processor. So this is an add override. I'll let it add that for me. Public Boolean equals, right? Parentheses and parentheses. Can't believe I forgot that. A little too much Python in my head. Alrighty. First thing we need to rule out is that they are not the same. Now, equals takes another argument of this thing that we are comparing to. We just need to see if, firstly, they are of the same type. If they are not of the same type, then they are not computers. So to be able to pass in multiple types, we need to make it, and whoopsie, we need to make it an object, right? The root class of everything. To see if something is an instance of a class, you use the instance of keyword, like this. If the other is instance, whoopsie, instance of computer, but if it's not an instance of computer, well, apparently that's not how you do it. I goofed that up. Alrighty, I just got to put the not like that, right? There we go. If parentheses, not parentheses, if the other instance of computer, right? Because if they're not, then we're going to return false. We know they're not the same. If we get here, then that means that they are of the same type. Alrighty? So, if name dot equals other dot name equals false, or you know, I should just put the exclamation mark there at the beginning, then return false, right? All right, why did that give me an error? It's because it thinks that other is an object. Other is, in fact, an object, and other does not have a name property. I need to cast it. It's safe to cast it because we know, you know, we could just use exception handling in order to get this to work, but we know, you know, that'd be all fancy and stuff, but we know it is an instance of, you know, so what are we going to do? I really like the keyword other so much that I'm going to change this to obj. I'm going to change that to obj, and then when I create my object, right, computer other equals, and it's a computer, so I'm going to cast it to a computer, obj. Now we're good to go, right? Our other reference really is a computer, so it's safe to do the comparison. If parentheses dot name equals parentheses, I forgot to say not. If not name dot equals, well, we've already covered name. Why don't we cover brand instead, right? Other dot brand, then return false. We have one more, right? Processor. If parentheses, not brand dot, oh, I already done brand, processor equals parentheses, other dot processor, in parentheses, return false. If it passes all the tests, we can return true. That's our others method. Now this is inherited from object, so we're going to add the at override annotation. All right, just as one more reminder, and I'm wind up losing my close parentheses, or is it down here lurking? All right, of what at override does. It forces a compiler to check to make sure this thing really is overriding. For example, toString returns a string, right? toString. But what if we decided that, yeah, I made a mistake and I called it void? You know, it is public, sure enough, but public void toString, right? It's going to complain bitterly that this is not the correct override for toString. Method does not override or implement a method from a super type, right? Oh, that's because it should have been a string. All right, what are we going to do? We're just going to return string dot format, right? Quote computer in %s, %s, %s. What are our brand, comma, or name? Like if it's an Apple Macintosh, I think the brand should come first, and then the processor, right? So brand, comma, name, comma, processor. All right, good enough. Now I don't feel like illustrating an abstract class with this because we've already done this before. What are you complaining about here? The if statement is redundant. Says who? Oh, for Pete's sake. All right, no, I'm going to implement that change. All right, watch extends computer. That means that we need to check to make sure that the color matches the other color. But firstly, I want to make sure where'd my method go? All right. So dot equals here needs to make sure that all the computer stuff matches, and then we can check to see the special field, right? So public Boolean equals, and it's going to take an object, obj, right? So we need to check, and I had a cheat sheet pointed up, sorry for that. I went to Stack Overflow to see how to do it. If super dot equals obj, what we're doing is we're seeing if our object is equal to our super object, right? To the one we inherited from. Right. Instead, we're going to check to see if that's false, right? So I'm putting an exclamation mark. If super dot equals parentheses obj, if that's not true, then return false. It's no good. Now that we know that, oh, it wants the add override notation, of course. Now that we know that, we can check our specific. So that means we have to cast it. Shortcut. And there's only one method, so I could use a shortcut for casting it like this. If. Nah, I'm not going to use any shortcut. That'll make the syntax a little bit harder, right? So watch other equals. I'm going to cast the obj to be a watch. Now we're going to check its member. If this dot color, and I skipped using this reference earlier, I'm not sure why, dot equals the other method, excuse me, the other member, other dot color. But we need to see if it's false or true, right? We could just return this. This is what it was kind of recommending on the last method, right? I'm not going to extend this with other elements. Or I'll do it the way I did it up there. If, parentheses, not parentheses, get rid of that semicolon at the end. There we go. If they don't match, return false, else return true. And now it's going to warn me that that's a redundant check. Right. Because I could have just returned the value of that comparison. But I like doing it that way because I might add more members and then I need to add more ifs down here. Alrighty. So how about a toString method for this? Well, this isn't a computer, so I don't really feel like calling computers toString method. Public string toString, right? So I'm just going to do a system format, but I'm not going to print out that it's a computer. I'm going to print out that it's a watch. So return capital S string dot format parentheses quote watch. I could still put the brand first, right? %S. Oh, how did I do it up here? Yeah, I did put computer first. I'm going to make that a capital C just to match it down here. Okay, so it's a watch. We're going to put the brand. We're going to put the name of the watch, right? And then we're going to put, you know, the processor. Not that people buy watches for their specific processor, but whatever. Alrighty. And then the watch had a specific attribute, color, so we're going to add one more %S down here. We've got a lot of attributes to fill in here, a lot of placeholders, so I'm going to, after the comma, go to the next one. And we're going to print out, you know, the brand. I wonder why I capitalized color. That was kind of moronic. I'm not going to change it though. This dot, no, I don't want to do color. It doesn't matter what order these things are in, right? Capital C, because that was dumb. All right. So we have a watch, we have a computer. I really probably don't even need, for this example, to give a phone example. Right, I'm just going to delete this, not to show polymorphism. Alright, so for polymorphism, that means that I can use different classes and have them treated the same way with different results. In this case, a different result is just going to be calling toString, right? I guess we should check to see if dot equals works. So let's make two watches. Watch W1 equals new watch. Did I make the color? And did I make all these attributes? See, I didn't make constructors. One of my rules, make constructors if it makes it easier to use. All right, it's an Apple Watch. So W1 brand equals, quote, Apple. W1 dot, you know, the name of it is equal to, you know, watch 4. W1 dot, you know, the processor on it is some kind of ARM processor. I could totally make this up, huh? I don't know. And then the W1 dot color, well, they only come in one color as far as I know, black. Dot process is grayed out. Why? Cannot find the symbol. W1 dot, what did I do? Spell it wrong? All right, what's your deal? What's your malfunction? Oh, I forgot to use an equal sign. All right, careless. So I have a watch there. Sure would be nice if I had made some constructors to make this easier, but whatever. So this is a new watch, right? And this is a Samsung, and I don't know if they make watches or whatever. And so we're going to call this, what is all? This is a Galaxy watch. I don't know. It uses a Snapdragon, right? I don't know. Snapdragon 42, whatever. It's also black. Now let's make a computer so that we can compare to see if the computers are the same, right? We're going to build an Apple, something powered by ARM 3.4, and it's black, but it's not going to have a color, right? And I forgot to make all these W2s, right? Okay, so computer C1 equals new computer. So C1.brand equals quote Apple. I should have just copied and pasted. C1.processor equals quote ARM 3.4 and quote semicolon. C1.color, whatever this computer is, it seems to be black, unlike real Apple computers at this point. They've made very few black computers. Except color is not a member of C1. So that's for watches. I need to get rid of that, but I need to put the name of it. All right. The name of it is also watch 4. Now this is stupid, right? Because if it was a watch, we should have made it a watch. This is just to test to see if our dot equals method works. That's the only thing I'm doing here. That's the only reason I made this ridiculous watch thing that matched the attributes of this, right? So this computer matches all the attributes of the watch. It's just that the watch has an extra method. Let's find out if they're the same, right? So system.out.println w1 dot equals parentheses C1. Let's find out if they are, right? Question mark space equals plus. Same thing, because we're comparing them, right? W1 dot equals C1. It'll print out either true or false. Let's find out if it does. That is our main class. Build failed. Why is that? Build successful. Okay, that was odd. Run it. Build failed. Exception. It failed in the watch dot equals. I was kind of afraid that that example was going to lead me astray. Maybe I should have done that right at the beginning, right? I didn't check to see if this object was a watch, right? I forgot that my instance up. Let's see if that magically fixes it, right? So if not, parentheses, obj instance of watch, right? It's not a watch, we're going to return false. All right, that did fix it. All right, so W1 dot equals false. They are not the same, right? Because a watch is actually not equal to a computer. How about if we change the name of it? Right, it's a Mac, right? All right, look. I know it's going to say false. I'm just wondering how far down there it gets. So I'm going to set a breakpoint and watch it. But it's still going to say that it doesn't match. So I guess I'm going to make this match, right? This is going to be a watch. Watch C1 equals new watch. It's totally botched data, right? Color equals black. Everything's the same except the colors. I don't know. But I still want to see if that super comparison works. That's what I'm trying to figure out, if the super comparison works. So I've tried to set them up to be exactly the same. Apple Watch 4, ARM 3.4, black. Well, if they're exactly the same, I should make the name the same, right? Watch 4. And again, this is just for tests. All right, Apple, ARM 3.4, Watch 4, black. Set a breakpoint, because I want to see how the comparison works. Build it, run it. What, did you generate an exception? Nope, you just didn't stop where I wanted it. All right, debug project. It stopped there. I'm going to step inside it. Step into. Okay. Well, that botched. All right, I mean by botch, it skipped it. Run it once more. Debug project. I may just accept it on faith if I can't step into it properly. Don't want to spend an inordinate amount of time on this. Step into, whoops, why did I do step out? Run it. Excuse me, debug project. I know one of the buttons up there is debug project as well. Step into, that's the down arrow. Step into again. What if I set a breakpoint here as well, just to make sure I get to that point? Right? Step into. All right, now it's a computer. Step over. Well, let's back out of it because it's done constructing that it's a computer. I never watched that before. Never watched it call the constructors like that. I'm just going to keep clicking step into the whole way until I get into one of the constructor. I mean one of the dot equals methods. Why don't I just do that? I should have done this all along. I'm going to set a breakpoint on dot equals inside computer, right? And I also did it here already, all right? So I should be able to run it. Oh, you know what? It's because my breakpoint is really on the constructor rather than on the dot equals method. If I scroll down there, I will see that I breakpointed the dot equals method. So I'm going to have to get out of it. Let's get rid of that one. I don't want the breakpoint there. I want it there. Debug project. Gets down here. We're going to step into it. Now we're in dot equals. We're in the watch dot equals. I don't need to step into the constructor of it when, well, that's not a constructor, that's just a check. But we know they're the same. Hope they are. Now we're going to see if this calls dot equals of the computer class, the base class, the super class. And in fact it did. Excellent. Okay, that was a long way to go in order to prove that. But that is how you check to see if the base information is the same, right? If the superclass's information is the same. So let's go eyeball that one more time, and I'm going to remove a bunch of constructors. What is that funny looking little dot? Has subclasses. Cool. I could go to one of the subclasses if I wanted to. Well, what's that warning? Generate missing hash code. I have a feeling I'm going to undo this real fast. Oh, neat. Alrighty. Well, I'm going to undo all that. Alright. Okay. We have a breakpoint there. We have a breakpoint there. I'm going to change this back to being a computer so that I can demonstrate polymorphism now. This is a computer. Right? Computer C1 equals new computer. Computers don't have colors, apparently. You know, we would probably make a laptop subclass and so on. Would it take much time to do that? I could just copy the computer class, make it laptop. I mean, I could copy the watch class, make it laptop. Why not? Why not? It'll make me feel a little bit better after all that last bit of fumbling. Let's do class watch computer. Copy the whole thing. These should be going in their own files, of course. This second watch is actually a laptop, and I don't think I need to actually change anything except for toString to say that it is a laptop. Right? So all I did is copy watch, paste it, change watch to laptop there and there, so that I can go down here and say that this computer is really a laptop. Laptop C1 equals new laptop. All right, time for polymorphism. We could stick these things into an array. We could stick them into an array list. Why not an array? It's going to be an array of computers though, right? Because these things both inherit from computers, and so that's the only type of array that would incorporate them both. Not strictly true. An array of objects would do as well, right? Because that's the ultimate superclass. So it's an array of computers. C array equals new computer subscript, and there's 3 of them. So C subscript 0, well, no, C array subscript 0 is equal to, you know, our first watch. C array subscript 1 is equal to our second watch. C array subscript 2 is equal to our first laptop. And I forgot to change this to a MacBook, right? And MacBooks have some kind of Intel processor, I don't know what. Pentium blah blah blah, I don't know what they're currently using. Pentium is old school. I'm just going to call it Intel because I don't remember. What you complaining about? This array is only written to or never read from? Yeah, no kidding. All right, and so we're going to make a for loop that steps through it. Why not just make it a for each loop for every computer C in the C array, right? String S is equal to C dot toString, and we're going to print that out. System dot out dot println parentheses quote computer equals end quote plus S, right? And I didn't have to do this bit. I didn't have to do this bit at all. I could have just put C here, and it would invoke toString automatically. So I don't know why I did it like that, but I'm going to leave it alone. Alrighty, what are you complaining about? Explicit type can be replaced with variable. Well, that's true. That's a catch-all for it. Well, I'd like to leave it as was. All right. When it runs, we're going to see polymorphism. These different types, they are of different types. One's a laptop, one's a watch. They're different types. Different types being treated similarly, but producing different results. Let's go. Now you went into something weird. I don't know why you went into that. What is that? Print stream. Oh, I need to stop debugging. All right. Run it. Or build it. Run it. And if we look, the first toString method knew it was a watch. The second toString method knew it was a watch. The third toString method knew it was a laptop. So we're calling different methods based on its type while treating them as though they are the same objects of the same class, right? A computer's toString method doesn't know anything about watches or laptops. So how's that working? We could go and we could delete his toString method entirely if we wanted to, right? That'd be totally okay. I wonder if we could even make it an abstract class. I'm going to try that. If you're following along, don't. But I'm going to make this an abstract class, and I'm going to make toString just have no body whatsoever. Can you override something when you make it abstract at the same time? Looks like a big negatory. Oh, I have to add the word abstract in front of it. And if I add the word abstract in front of it, all right, looks like that worked. Looks like I have declared that the subclasses actually have to have a toString, right? Even though toString is inherited from something above, we're kind of wiping out the above inheritance. So now we absolutely know that this is not calling computers.toString down here in the array, right? We're not calling computers.toString. We're absolutely calling laptop toString, and we're calling watch.toString. And we could come up with another example, you know, involving geometric shapes. We're calling get area for a triangle would use one formula, and get area for a square would use another one. So, class shape. It's an abstract class. Why did it complain about my curly brace? Because I put parentheses there. All right, it's an abstract class. Every class. Let's make it an interface instead, just for funsies, right? It's an interface shape, and they all have an abstract method. You can leave the word abstract off, I believe, if it's an interface, but I'm going to put it there anyways, called area, or get area, right? And now we're going to make two shapes, right? Interface triangle. Well, it's not an interface, it's a class, right? Class triangle has to implement get area. Triangle has two pieces of information, right? It has a base. Oh, why don't we just make this a square and a circle so we're only tracking one thing, right? A square, we're going to make a constructor for it, you know, so it's public square, parentheses, you know, int radius, well, radius, side, int side, you know, and it sets this dot side equal to side. I did, in fact, forget to make a member for it. One of the funny things is NetBeans will offer to fix that. No, it won't. Cannot find simple. Quite often, it'll offer to create the member for you. Int side, right? And then a get area for it, right? Public double get area. Why didn't I make the side a double? I should have. Why not change that? Double side, right? And get area is just side times side, right? Return side, asterisk side, semicolon. Now we're good to go. We're going to make a circle. Instead of a side, it's going to have a radius. But this class is really a shape. So we put implements shape. You don't like that, do you? Why did I make get area a Boolean? That makes that go away. All right. Circle's the same thing. Class circle implements shape. So double radius. Add a constructor, public circle, double radius in parentheses, sets this dot radius equal to radius. And notice it's complaining because I have not added a get area method. And since we said that it's a shape, it has to have a get area. So public double get area. which is going to return pi r squared. Return math dot pi times radius times radius. I wonder if there's a specific radius slash side where they are the same area. I'm not going to figure that out. My guess is no. As a matter of fact, unless it's 0. Yeah, if they have a side of 0 and a radius of 0, then that's the only time that they have the same area. All right, I could do the same thing that I did. Here, I'll pause, go back and look at this, right? This is my class. Why don't we add the override annotation? This is my circle class and my shape class. This is my square class. I can scroll down to main. Do the same kind of business, right? Square S1 equals new square of radius 10, well, of side 10. Circle, better not use C1, I think I used C1 else, so how about, it's still a shape, so I'm just going to call it S2, equals new circle, radius of 10. I'm going to make a method up here that prints information about each one, right? Public void print area, you know, and it takes a shape. And it's going to call get area for each one. So double area is equal to the shapes dot get area. And then we can print that out. System dot out dot print ln. Shape area equals end quote plus area. So let's call print area with shape 1, print area with shape 2. And yeah, if we'd added a toString method and stuff like that, it'd look a lot better. I wonder what I'm getting complaints about here. Non-static method. Okay. Public static void. Right. Had to change that. What's your complaint now? Exporting non-public type through public API. Whatever. All right. Run it. It's going to be able to call get area on each object, even though it thinks that these objects are shapes, and shape does not have an implemented get area. But it will call circles get area or squares get area based appropriately on whether it's a square or circle. So we have objects of different type being treated as though they are objects of the same type, but with different results. So we should see two different areas, even though they have the same radius inside. And that's correct. All right. Hope that made sense. I really think that's enough about chapter 14. We can go take a peek. Right, we've covered equals, we've covered toString. Defining your own toString, your own .to equals. Polymorphism is when different types of objects respond differently to the same method call. I guess that's a better definition than what I was giving, my colloquial definition. Polymorphism is when different types of objects respond differently to the same method call. To implement polymorphic behavior, declare a general type of reference variable that is able to refer to objects of different types, just like we made a shape. A shape can hold both a circle and a square. Then when we call toString, it will call the dog's toString and the cat's toString, or in our case it called phone and laptop's toString. And their example of polymorphism. Dynamic binding. Dynamic binding is how it's able to call get area of the correct type, even though it thinks that it's a shape, right? And shape doesn't have an implemented get area method. But dynamic binding means that when it runs, it figures out that it's supposed to call the circles get area method, as opposed to the squares get area method. Polymorphism is when different types of objects respond differently to the exact same method call. Dynamic binding is what the JVM does in order to match the polymorphic method call with the specific method it needs. You can read how that happens. You should always read the chapter, even if I only give one lecture on that chapter. Polymorphism with arrays, that's exactly what we did, right? We stuck both a laptop and a watch into an array of computers, and then it exhibited polymorphism. Abstract methods and classes. We've covered that in 2 lectures. And now you know, even though it's not in this chapter, that interfaces are a specific kind of abstract class. The difference being is that an abstract class, your subclass can only inherit from one superclass, but it can implement, put quotes around implement, as many interfaces as it needs to do its job. That's a way to get around the fact that Java does not allow inheritance, making superclasses of multiple, right? Subclass cannot extend multiple superclasses. C++ can, and it can get into a really hairy, complex hierarchy chains. Java kind of simplifies it, separating them. You know exactly which class it's inheriting from and how it's doing so. The protected access modifier. Protected means that it's an element that is acceptable, that is accessible, both to the class. It's like private, but private, let's just go and give an example here, right? In our computer class, if we made this private, whoops, that's not the computer class. Where'd computer class go? Now, all right, I put it up here. If we made these guys private, we would break our code, right? I could go down here and prove to you that all references to, name are now failing, because private means that the only thing that can access this specific variable is code that's within the computer class, not even any of the subclasses. But if you make it protected, you protect it from the outside world, meaning that down here in main, where we were setting, these things, I really don't think it's going to work. I'm not seeing the red arrow down here. How'd that work? Name is protected. So how's it setting name here? That is a complete and utter mystery to me. Because if it's private, it would not be able to set it. Nothing is changing the access level. I've been using object-oriented programming for about the past 18 years, and I've never noticed that before. I just always assumed that if it was protected, it's not accessible to the outside world. That is absolutely true in C++. I thought it was true in Java. I guess we better go read the PowerPoint again. Protected, it's somewhere between public and private. Protected members can only be accessed by classes within the subtree associated with the member class. Now see, that's what it's saying. Then how is he accessing name? Is name not protected? Is name not the one that I made protected? Well, one of them would be false, right? If I made these all protected, it absolutely should not compile. Or is it just not going to run? Is it going to generate an exception? It should not compile, because that's flat out wrong. Main should not be able to change those values. Lo and behold, still works. You got me. Don't know. That's what protected is supposed to mean. that only that class and its subclasses can get a hold of that variable, and outside code, client code, driver code, the main method, whatever you want to, however you want to refer to it. Now what is this morning? Oh, the hash code business. Well, alright, so I'm going to leave those protected because, you know, our rule of thumb is data private, methods public. We could make it data protected, methods public. I'm still kind of boggled by that. If I was a Stack Overflow member, I would pose that. I may research that a little bit. Never ran into that. The book seems to be indicating my prior belief, which is that main should not be able to change those variables. They should only be allowed to be changed by methods inside that class. In other words, I should add a constructor that sets those three things, or I should add setters. And yeah, I could do that, right? I could select those three things, go refactor, encapsulate, boom. It has added setters for all those and fluffed it up with a lot of unnecessary comments and stuff. Now when I call down here, write set brand, set name, set processor. And I should make the color methods of the watch and the... Did laptop not have its own member, or did I just forget to set it? What was laptop's special member? Oh, it also had color as its special member. That's kind of silly. If color is a member of all of the subclasses, it should be moved up to the superclass, right? Because every laptop has a color and every watch has a color. So it's inappropriate to make that as a special member of the laptop class and of the watch class. I'm not going to change that. You do have the idea. But it should have getters and setters, right? So I can encapsulate that. Good luck for those of y'all who are reading the notes for this. I'm going to undo the last change, right? Undo the encapsulate fields. Because once you add the getters and setters, your code becomes, you know, the class is twice its length if you leave the comments and stuff like that. And yes, you should add them. Absolutely, it's good programming to add your getters and your setters. Just for the example, I'm leaving them off. All right, I think that's enough. We've done chapter 14. We've done chapter 14 by the fact that we've already lectured about dot equals and toString in several lectures, and we've already talked about abstract classes. The only specific thing we added to this, although I thought it was appropriate to rehash the other things considering their importance, is the idea of polymorphism, where all of these guys are treated as though they are computers, even though some of them are specifically watches and some of them are specifically laptops. Or up here, we treated them all as though they were shapes, right? Even though some of them were squares and some of them were circle. All right, hope that made sense. Usually, I give an assignment on this, and it usually involves kind of the geometric shape example, where some of them have volumes and some of them, you know, only have surface areas and stuff like that. But our example code from the last lecture demonstrated a lot how to do that, so your answer would probably be just to go and grab that code, unless I came up with a different one. And it's at the end of the semester, and I want you to be working on your projects if you have not finished them. All right,